Hello everyone, welcome to my channel EE1. In this lecture, this is the lecture number 3 and it's going to be a lengthy lecture. That's why I have divided into two parts. And this part I will be discussing the spherical coordinate systems and what are the coordinates. We have to define those coordinates and the relationship between these spherical coordinates to rectangular coordinate systems. Okay, so now what is the spherical coordinate system? It is based on sphere. This coordinate system is based on this sphere. It's like a football. So as we know that the coordinate system, this is just a system, okay, orthogonal coordinate system. So why this coordinate system? We know that each and every point and each and every quantity in space we have to define in degree. Clear? So as we define any point in cylindrical, circular, cylindrical coordinate system. So any point, if we define in rectangular coordinate, we can create into cylindrical coordinate. Okay. But here the same. So now why this coordinate system will be going to use? So because of this, the spherical coordinate system, if some symmetric problem is there, means degree of symmetry is some application, if you find the degree of symmetry, so you have to go for this coordinate system. Okay. Otherwise, as I told, simple one, the rectangular coordinate system, if the dimension up to limit up to 3 dimension, then go for the rectangular coordinate system. Okay. So here itself, this is also three dimensional system. So now many of you can face problem. Suppose to get some crystal idea of this coordinate system. Okay, what are the surfaces? How this transform gets? Okay, so now I am here with some 3D explanation. So with that explanation, I think you will get much better understanding. Means what have you already? Okay, that I think you can overlap with that. Okay. So now, what are the coordinates of spherical coordinate system? The coordinates are r, theta, or phi. Most of books using this notation. Okay. You may change this r as a row, means whatever your notation may be. Notation doesn't matter, but you have to define these coordinates in the manner will be same. A definition of these parameters, maybe parameters are different. Okay, but you have to define in the same way. Okay. So firstly we have to define these parameters. What are the parameters and what are the limits? So let's go into 3D mode configuration. So there we will be defining these parameters, or these are the coordinates in spherical coordinate system. Clear? So now see, here I have taken this configuration for different purposes. Okay, for the time being just you neglect this conial surface, you just neglect this one. I will be using later some purpose is there whenever we will be dealing the surfaces. Now see here, I have taken this two hemisphere. Here one circular surface, that is plane I have taken. Okay, just it will be the parallel to the parallel to xy plane. Okay, so now suppose if these are the hemisphere, so if you join at this point, if you just this hemisphere just drop down to this and it's just up at this, so you will get a complete sphere. Okay, but now my understanding about this is R. What is the R? Means we have to define the R, theta, phi. So firstly, let's go for R. So what is the R? So firstly, you have to take the origin point. Okay. Suppose origin point or the point of reference we have to take. So suppose this is the origin. For this, just this one is the origin. So this is the origin point. Origin point. So if that is origin, so what we have to take? So we have to go with that the origin. If it is origin, suppose this is a complete hemisphere. So from that origin to any this curvial surface, any point is there. Suppose lot of points, a million points are there on the curvial surface. Okay, from origin to that point, that any particular point, if you take that point is for a sphere all the time will be same. That is nothing but the radial distance from origin to that particular point. With that, the surface one sphere is the sphere is getting. So that is known as the R. That means radial distance from origin to that particular point. That any particular point on the curvial surface of this sphere. Okay. So this is the R. So now simply you can say the limit of this R is what? From origin, that means 0, and it can be extended up to what? The infinite. It can be infinite. Suppose here it is origin, it can be infinite. So the R, limit of the R, so limit of the R will be infinite minus 0 to infinite. Okay. Now we can go with the theta. What would be the theta? Okay. So for that explanation, we have to take that what is the axis of that. So axis would be for this sphere, we can consider the axis. What axis is one line is passing through the origin. Okay, that is we are taking as a reference line. That means for this case, the z axis, along z axis nothing but this way x, this way y, and this way is a z. Okay, so z axis this way, z axis. So z axis is nothing but the reference line. Okay, so what would be theta? theta would be the wherever the r, suppose any point in this space, I am considering suppose here one point, suppose this point is suppose p x y in case of Cartesian coordinate. Okay, in Cartesian coordinate the notation x y z. So if any point is, so what would be that, from that point to that is, from that point to that, this point to the origin, up to that origin is r, will be considering r. If that is r, okay, so that distance will be getting from that to that, the radial distance will be getting called as r, and this r, what angle is creating between this z axis and that r is known as the theta, but the direction of that theta will be in the clockwise direction from the axis, from the z axis, from the axis to that r. So in this way will be the theta. Suppose here one point is there, suppose in this point, okay, so what would be the, this would be r, suppose anywhere, this point is r, any point p, so this would be r, it could be here, it could be there, and anywhere could be, and the angle between this and this would be theta. So theta, what it could be, maximum up to, it could be, if we consider here, 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 so from here to that point means what, in this way, from clockwise direction if we take, then theta is going to be 180 degree, that means pi, 0 to pi. Okay, but it is defining as that the angle between z axis and the radial distance. Okay, so radial distance, it could be what, any point on the surface, and this r is defining what, radial distance from that point to the origin. What that is, what is the radial distance, that is the radial distance, and this radial from this r is what, the angle between this r and the z axis in the clockwise direction. Clear? So clockwise direction means in this way. Suppose if we take the one point like this, like this, like this, you can take this way. So the theta is increasing in this way. Okay, in this way, the tangent of this, in this, any point suppose there, and tangent this way is the theta direction, and the r, direction of r is radially outward from the origin to any particular point, so that radially outward means it could be in this way, it could be in this way, it could be in this way, but it is radially outward. Okay, the direction of r, unit vector r, and the phi. Now in the lastly the phi, what, the phi is the same as what we define in the cylindrical, circular cylindrical coordinate system. So what was this phi? So phi is nothing but the angle between any particular point, but this point is what, with respect to positive x to the anti-clockwise of that particular point, how much angle is creating. Suppose any point here I take here any point, so that point is here. So just simply you take one circle on that. If you take this circle, okay, and now if you cut this, slice this sphere in this way, and what you will get like this one surface will getting. Okay, so now just similar at this point, what you will be getting, suppose this point is P. Now what is the angle between, this is x, positive x, so with respect to that anti-clockwise, how much angle? This angle is this angle is phi. So the at that tangent is in this way, so that is the a theta. So that angle is a theta, a phi direction. So what finally we got the limits of this. So r is nothing but infinite, 0 to infinite, and theta is pi 0, and the phi is the same as the circular cylindrical. So how this pi, 2 pi is making? See, so from this origin, positive x-axis to just if you travel in this way, so what we will get? We have to travel up to 360 degree, that means 2 pi. So 0 to 2 pi. Okay, to cover up. So this is the limits. These are the limits of the coordinates, and the coordinates are r, theta, phi. Clear? Now, as we know that this is also an orthogonal coordinate system. So what? This r, the surfaces are the surface r equal to constant, and theta equal to constant, and phi equal to constant. A r, a theta, a phi. These surfaces are mutually perpendicular. That means a r, a theta, and a phi. A r, a theta, a phi. These unit vectors are mutually perpendicular. Okay. So this surface will dealing about will discuss in the part 2. Okay. As of now, we will be discussing the conversion of this, the transformation of the direction. This direction a r theta, a r, a theta, a phi. What would be the components of a r in the rectangular coordinate? Ax in terms of ax, ay, az. And what would be the magnitude relationship between these spherical coordinates and the rectangular coordinates, and what would be the vector is direction relationship between the spherical coordinates and cylindrical coordinate. Okay, so now see the unit vector. We have to as we know that we have discussed one more point in the lecture number 2. So the first lecture, in case of first lecture, we have discussed the coplanar vector. So what are the coplanar vector? We have know that any vector if in the same plane, we can divide into 2. Okay, but here passing through a plane. So what we have to divide into? We will be getting the 3 components. Firstly, one component in parallel to the plane, one parallel to the plane and another component is another direction. Okay, so we will be dividing this AR, A theta and A phi in three components. Okay, in three components means in AX direction, AY direction, AZ direction. Clear? So now see the directions. Now see, this is R, and also anywhere we consider this point is R. This point is R. This any point P. The P is presenting as a P, X, Y, Z. Clear? Now the R from that origin to this point is R. Distance is R, and it's going up to this direction, increasing up to this AR direction. It will be in this direction. So from this to this, okay, this R, P point. So if you see this to this one component, this is R, AR component. It increasing in this way. So now what would be the, we can consider this as a R, as a right angle triangle, we can consider AR. So if it is AR, okay, angle AR, so with this hypotenuse we can consider, and in this way one, just I am drawing one line. So that line, and with this line and this axis, what we know, this R and this axis line is theta, this one is theta, and if from origin to this in this way, so what we can get the component, so we can get one component towards the, this is the base, no sorry, this was this is the angle theta with this, so this is the base. So base is what, it would be acting in this direction. So what, the AR cos theta, and this direction, it would be the parallel to the this plane, xy plane. In this way, what would be getting, just this one parallel AR. If this is cos theta, it would be the sin theta. Okay, just it is up to this. Okay, because we have considered here a right angle triangle, the 90-degree angle would be this 90 degree with this and this, and this is the hypotenuse R, AR unit vector, the magnitude is 1. Okay, so up to this would be the AR sin theta. Okay, now as we know the coplanar vector, this is same plane, there is a parallel to this plane, xy plane, this vector is AR sin theta. Now as we know that this angle is phi, so what we got in this direction, we will be getting what, AR sin theta cos phi, because this is phi, so AR sin theta cos phi, AR sin theta cos phi, and this direction we will be getting AR sin theta sin phi. Clear? So we got this, the AR direction is divided into 3. In the x direction, AR sin theta cos phi, In the y direction, AR sin theta sin phi. In the z direction, what? AR cos theta. Okay, these are the components of AR in terms of AX, AY and AZ. Clear? Now if we go with this theta. So theta, what we know, that theta is in this way acting, in this way. Sorry, AR. Well, as we know that AR, A theta and A phi, those are the mutually perpendicular. Now if we consider this, if this way acting the R, this way acting R and theta, R and theta is how much angle? The 90 degree angle, AR theta and A theta and AR. Angle between this AR and A theta is 90 degree. So as we know, this angle is what? Theta. And with this, if A theta is acting in this and AR acting in this, so there would be angle between AR and A theta 90 degree. Okay, AR and A theta 90 degree. So what would be the angle if this is the Z and it would be acting in this theta? Suppose here also we can consider as a right angle triangle. Suppose just if you get the better explanation, just for the this is X, this is Y, and this is Z. Clear? So if we consider the at origin, so maximum what? Suppose if you draw one circle, so one circle will get, we consider at the top, here it is 0 radius circle will get, and in the negative direction also 0 radius and radius is increasing. Suppose here in somewhere it would be the less radius, and anywhere what we considered, this is R, any point, sorry, this is P, X, Y, Z we consider. So from this point to this is towards this way, this is R, and what? With this and this, with this and this, what? In this way, this is the theta. So as we know, this angle is theta. So if you see that this is theta, just if you tend in this way, so in this way what you will be getting? This is the 90 degree minus, this angle is 90 degree minus theta. Here it will be the 90 degree, because angle between AR and A theta is 90 degree, actually perpendicular, no? 90 degree. So if you consider this A theta is increasing in this way, so means if you see here, so A theta is just in this way, increasing in this way, okay, increasing in this way. Just here we have considered this hypotenuse, and this angle is 90 degree minus theta. Just see, this angle is 90 degree minus theta. So in the same way, what we will get? So in here also you will getting one, this angle, this component and this component. So this is the hypotenuse, this is angle 90 degree minus theta. So this would be the, so with this theta is acting. So theta in this direction is acting. So one component will be getting in the down along z, and along this will be getting one component, that is what? That this component would be, and this component would be what? The cos sin theta, a theta sin theta, and this component would be the a theta cos theta. Clear? See, so this component from this point to this point, this component what would be a theta sin theta, and this component will be a theta cos theta. Okay, so this component is the reverse direction of z direction. Okay, a theta sin theta, and again we got one component in this way of a theta component. So a theta cos theta. So there also be two components. So in this way, what component would be? In this way, a theta cos theta sin phi, a theta cos theta sin phi, and this way what? A theta cos theta cos phi, a theta cos theta, a cos theta sin phi, a theta cos theta cos phi. Okay, for theta component, and lastly the phi component. So phi component as usual what? The phi direction of phi, a phi is in tangent of that point in this way. So it is nothing but what? One vector we can consider in this way. So what is the angle between this? This angle is what? 90 theta, and this angle is 90 degree. So this angle will be the 90 degree minus phi. This angle would be 90 degree minus phi. Okay, so if it is increasing in this way, phi, so what? Along this one component will be there, along this one component will be there. Okay, so along this what component will be there? Along this and along this. So along this reverse direction of x, sin phi, in this component it is sin phi, a phi, this component will be cos a phi, but this is the reverse direction of x. Okay, the reverse direction of x. So now finally if you see, for AR component, so AR component we got in the x direction, y direction, z. What we got? The sin theta cos phi AR and sin theta sin phi AR in the z direction cos theta AR. Okay, but in case of Z, we got a reverse direction in case of theta. Theta, what we got into AX direction, along AX, along YY, along Z. So, X, Z. So along X, what we got? The cos theta, cos phi, A theta. Okay. Sin, this is also cos theta, sin phi, A theta. This is the sin theta, A theta. Because this is negative direction, because we got this component as the reverse direction of Z. Okay. Now this is the minus sin phi, A phi. This is the cos phi, A phi, and there is no component of Z. Okay. So this is AX, AY, and AZ. We got the parts, the segment of acting segment of this AR, A theta, and A phi. So we can simply write this way. So this we could write AX. See here, we can write this way. This component AX, AY, AZ. If we simply use the mathematical tool, some matrix AX, the direction AX, AY, and AZ. So direction you can get into this form AR, A theta, and A phi. Clear? So this is the matrix 3 by 1. This is 3 by 3. This is also 3 by 1 matrix. Okay. So from that what we can just get. So if we know this component AR, A theta, phi, so you can get into this AX, AY, and AZ. Okay. In terms of, now this is nothing but the relationship between the AX, and in the same way you can get the AR, A theta, and A phi. How can we can get it? This is the A, so this is A inverse, this is AX, AY, AZ. Okay. As the same way we discussed in the cylindrical coordinate system, this it is the relationship between the unit vector relationship between the Cartesian coordinate and the spherical coordinate 3, 2, 2, 3, 2, 2, 2, 1. Okay. So if it is 1, okay, if it is 1, then what would be this AR, A theta, A phi? Hence we will get A inverse, get this magnitude is magnitude of A is 1. Hence we will get this A inverse is like this. Okay. So remember these things. This conversion matrix, magnitude, the direction conversion matrix, this is known as the direction the direction conversion matrix. Okay. So, and now the magnitude. What is the relationship between the magnitude? So see the magnitude. What is the relationship between magnitude? So as we consider that this point is any point P. So from origin to that point is R. So simply this R point with this axis and this R angle is theta. Angle is theta. So here we will get the relationship between R theta. Okay, so this one component we will get what? It is theta. So what will be the component? So this component would be the R. This component will be what? This component will be Z equal to R is base. So R cos theta, and this angle, this magnitude of this is the R sin theta. And now the component of X and component of Y. X component will be the R sin theta cos phi. Y equals to R sin theta sin phi. Okay. So this is the relationship, magnitude relationship. X equal to R sin theta cos phi. Y equals to R sin theta sin phi. Z equals to R theta. So from this relation we can simply write that R is equal to x square y square z square. Okay, R theta would be the cos inverse Z by R. R the root x square y square z square. As we know that R is R minus infinity, that is phi equal to pi. Phi is same as tan inverse. If you divide this into this, so tan inverse x. Yes. So with this I am going to end up with this part. So in the next part I will be discussing the surfaces and the one example to establish the transformation from one to another and vice versa, and the special sum cases will be considering that. Okay, thank you all, God bless you, stay safe.